and welcome to Module 5 in Video Lecture 2. This is going to be another short one. We're going to be covering only the first part of relations, basically what are relations. In the second module relating to relations, we'll be dealing with more detail on relations, but now just the definitions. So we said before, at the most basic level, a function was a mapping between elements in a domain to elements in some range. Right? It links two different things, two different elements of two different sets together. A relation is sort of the same thing, just a little more general. A relation can be any linkage at all. So it could be a familial linkage. It could be adjacency, either physical adjacency or social adjacency. It could be the relations that you're familiar with, like greater than, equal to, less than, greater than, less than, equals. These are relationships. Any relationship at all can be represented as a relation. They compare elements of sets. At a fundamental level, relations compare elements of sets. They describe how they're related to each other. The most common kind of relation, although not the only one, is a binary relation. A binary relation compares elements two at a time. So it compares one element to another element. We will often call these elements, these relationships, R. R strictly means A is related in some fashion to B. This could be, as I said, lots of different possible relationships. And in general, you can create a whole large mathematical formalism based on these relationships. We are not going to do that here. We're going to focus on one and only one type of relationship, not including the whole functions that we had just spent several modules doing, which are also types of relation. So I guess we should say we focus on two types of relation. One is a function, but two is a relation between objects that's very commonly used in decision theory and social choice theory, which is the relationship at least as good as. So let's write that one down. So we're going to be dealing with R is at least as good as. That's very closely related to the greater than or equal to sign. The difference is this sign applies only to numbers that have certain properties we'll get into, whereas R applies to any elements of any sets. All it means is one is at least as good as the other. I should say before we get there, how do you read R? There are other ways to read R, but we're going to focus on this particular way. At least as good as. We can break that up into its components, just like greater than or equal to can be greater than or equal to. At least as good as can be strictly better than, which we'll call P, or indifferent between, which we'll call I. So we can have A is strictly better than B, or A and B, I'm indifferent to either of them. Either one is fine with me. I'm indifferent. This is the most common relation used in choice theory because at a fundamental level, choice theory is about making choices, how to make the best choice for you. To make the best choice for you, you have to have some notion of what you like better and what you like worse. These relations provide that notion. So these relations are at a fundamental level, are the fundamental thing that's important in choice theory. And the reason we care about that is not just for choice theory or social choice theory, but because these relations directly characterize our preferences, and our preferences are the fundamental thing that enters into utilities, which are the core concept behind all of game theory. So these preferences and these relations are fundamental to understanding both decision theory and social choice theory and game theory and utility theory and pretty much any variant of that involves what you or I want. So that's it for this one. And again, as a passing aside at the end, I'll mention you could do other relations, right? I mentioned before we're only dealing with one, but there are other relations. Let's say you have a set that consists of the old apple, banana, and orange, and another set D that consists of drinks. There's tea, and there's coffee, and there's some energy drink. Well, you might relate the fruit you like best in the morning to the drink you like to wake up with in the morning. Those are different kinds of relations. So you might say that that B is related to T. These are different kinds of relations. Again, the only relation we're going to deal with is the at least as good as relation, not counting the existence of functions as a whole. Okay. So what we're going to do next, the next module, is go through this particular at least as good as relation, see how it works, see some properties of relations in general, and then use that to derive utility representations. Thank you.